Okay, let us talk about our course, Principle of Steel Design, but still is under the laboratory part or the computation part. So let's start the computation, the basic ones, the very basic principles. So the number one actually is about allowable tensile stresses. So there are two major types of stresses when we are talking about strength of material. We already know about what? Compression and tension. So under tension, that is what we call tensile stress. Okay, tension. Okay, so allowable tension. How much is the allowed before it breaks down? So it gives us an idea that this might be the what? The maximum that the structure could carry. Okay, the maximum that the structure could carry as designed by us, no? As designed by engineer, no? To carry this amount of load. So that is the maximum. Okay, so let us define something. Okay. So letter A, gross area. For gross area. So when we are talking of stresses, we usually need to compute area because load divided by area, that is the stress. That is the amount of stress. Okay. So first, let us talk about two different types of areas, what we call gross area and net area. So for gross area, so the allowable tensile stress, so tensile stress is actually 0.6, okay, 0.60 Fy. Okay, so that is the allowable. Okay, okay, so we can call this as F, no? Allowable tensile stress is equal to 0.6 Fy. Okay, so or since this is tensile, let us say T, Ft is equal to, so let us discuss our convention. If we are talking of capital letter, right, that is what? The characteristic of the material, capital letter. But if we use small letter, for example, small letter F, T, that is also a tensile stress, but that is now a computed or calculated type of stress. Okay, so let's use that convention. So for letter B, okay, so okay, that is the number one concept. Number one concept. For gross area, when we are talking of steel still members, still component, still element. If we are using gross area and we are going to find out the tensile stress, so the allowable is 0.6 times Fy. So what is Fy? Fy is the yield stress. Okay, so pure. Take note of pure. Okay, so as we talk about these things, just the previous module, okay, pure, okay, proportional, elastic, yield, ultimate, and rupture. So Y meaning yield. This is the yield tensile stress. That is the tensile stress at the yield point. So do you imagine now where it is located? If I ask you, please find in the graph where the yield point is located. Can you do it? So that is why we need to understand the previous module. Okay. Right. So next is for those steel sections with holes for bolts or rivets. The tensile stress, okay, so is equal to 0.5 FU. So meaning to say, this gross area, these are those without, okay, without holes. Without holes. Okay, so these are those with holes for bolts or rivet. Okay, so 0.5, this is 0.6. Take note, this is FU. Okay, okay. Oh, okay. If I ask you, which of the two is greater? Can you answer that? Which of the two is greater? Right. So you have to go back to the previous module in order to have an idea. Okay. So Fy, Fu. What do you mean by Fu? This is the ultimate tensile strength. Can you plot it on the graph? The U, the point U, the ultimate point. Can you plot it on the graph? Okay. Also, okay, when we are using the design, we are actually using the yield point most of the time. Okay. Now, take note, 0.60 is actually 60%. We are just using 60% of this to be used as our allowable tensile stress. Okay? So 60% only of the yield stress. Okay? Now, can you divide or can you imagine how many percent decrease when we increase the temperature from ambient temperature to 550 or 600 degrees Celsius? So it is about 70%, 60% to 70%. So it is very near here. That's why the possibility of failure at 600 degrees Celsius or 550 degrees Celsius, even 500 degrees Celsius, is higher. The possibility of failure. The risk of having a failure at that temperature is great because it is very near our target allowable, meaning the maximum allowed load. Right? Note. Okay. So this is what? Specified minimum tensile stress. Right? This is minimum yield stress. So all of them usually, if we are using what? SI unit, stress is what? MPa. That is in terms of megapascal. Okay? This is in terms of megapascal. So if we have this type of equation, therefore, what? So using NSCP, what is NSCP? Right? National Structural Code of the Philippines, capacity of members with what? Bolt or rivet. Okay? Is what? According to NSCP, is what? Is the smaller. Okay? According to NSCP, the capacity of the member with bolt or rivet is smaller. Is the smaller. Why is the smaller of the two values? Okay? What are those values from this one and this one? So let us have this tensile. Okay. And again, we have what? Tensile. So this is not stress. This is tension force. This is force because this is stress 0.6 Fy multiplied by area. This will become force. So tension force. Okay. So this is what? 0.5 Fu. But now it is what? Effective. Okay. So this is what? Gross area. Gross area. Gross area. This is gross area. Okay. AG. Gross area. What do you mean by AE? AE is effective net area. Okay. So what is AE? AE is equal to actual effective area or effective net. Okay, sorry, net area. So we have the word net. Okay, actual effective net area. So therefore, this is actually equal to UAN. So net area times U. What is U? Reduction factor. Okay, U is our reduction factor. Okay, reduction coefficient. So some reduction coefficient times net area, that is effective net area. Okay. Okay. So okay. So U. Okay. So you can now what? Screenshot. Then let's go to the next page. Okay. So for For pin connected. What do you mean by pin? Okay. For pin connected members,